video, we're going to program the part that we had drawn in an earlier video. So there's a couple things that we need to worry about before trying to create the program. First is going to be the stock. So we'll draw a rectangle for that. We'll click on Other, Rectangle. In this case, I'm going to use a 7 by 7 inch rectangle with sharp corners. I'm going to place the origin at the center of the rectangle at x0 and y0. So that just defines what we're going to cut this part out of. Now we also have to deal with start points for any profile cuts that we're going to take, like this outside shape. So what we'll do is we'll put a break right where we want the part to start cutting at. Let's say we want to start cutting in the center of this radius. So we'll go to Utilities, Break, and then Divide. We're going to break this arc into two entities, so we'll leave number of divisions set to 2. I'm going to select the radius, then right-click and left-click OK. What this does is it just breaks the arc into two objects. So this will give us an entry point where the two objects join. So we're going to click on Other, Contour. What this will do is it will group the objects together, which will be the shape, and also set a direction. In this case, I'm going to go clockwise. I'm going to use Automatic or Select Start Point Automatic. Hold down Shift to do chain selection, and click the end of the last line of cut. Then right-click and left-click OK. And this groups the entire object together and sets a direction. Now we're ready to actually start adding our toolpath. So we'll come over here to our cam tree. And we'll see up here we have milling stock. Below that we have soft steel. I'm going to right-click and go to Edit. Let's go ahead and change this to aluminum, or in this case, let's say hard steel. This will help set up the feed rates. Then we have stock geometry. You'll notice that there's a little red dot next to stock geometry. What this shows is that nothing is selected for the stock geometry. I'm going to right-click, then choose Reselect, hold Shift, and pick the outside rectangle. It's not necessary to select stock geometry. However, if you do, this will specify the size of stock for the simulation, as well as for 3D toolpaths that can also make a boundary. So we'll right-click, then left-click OK. Now we can see our stock on the screen. I'm holding the Control key and using the right mouse button to rotate. Now we can see that the stock defaulted to 1 inch thick. What we're going to do is change this. So we right-click milling stock, and then go to Edit. This gives us our stock definition. We're using rectangular stock. In this case, we already said it's hard steel. Our top of stock is going to be set 0 in this example. And the thickness, let's say, is 1/2 inch. Our rapid plane for clearance, let's use work offset 1. We'll click OK. And now our material is updated. Now to add the pocketing routine in the center of this part, I'm going to go back to a top view. To add the toolpath, we're going to right-click milling stock. All of the toolpaths are located in this menu. We have drill, mill 2-axis, and mill 3-axis. In this case, it's a 2-axis cut called pocketing. Loads a feature pocket. Everything below this feature pocket has to do with this pocket. A start point and geometry. It's necessary that you at least select geometry. Start points are optional. In this case, we will not be using a start point. So I'm going to right-click geometry, and just like the stock geometry before, has that little red dot next to it indicating that there's no stock selected or no geometry selected. So we're going to go to Select. I'm going to hold Shift to do a chain selection, pick the rectangle, then right-click and left-click OK. Then right below geometry is the word pocket. We'll right-click, then Edit. This gives us all of our options for the pocket toolpath. First is our approach and entry, which we'll use rapid plane point 1, which we have set in a previous dialog box. Our top part set at 0. Now we'll see for the material entry it gives us choice of plunge, ramp, or spiral, and clockwise or counterclockwise if we choose a spiral. Let's just plunge in this case. We'll go to Patterns, Lay Zigzag, which will just cut back and forth with an angle based off the x-axis, or an offset pocket, in or out. Let's use offset pocket out. This will start from the center of the pocket and then work its way towards the outside. Our cutter width percentage, or step over, let's say 50% of the tool. And we'll climb mill. So we'll click on the climb mill button. Rough side cleanup is for running a finish tool after the pocket has been cleaned out. Let's go ahead and do that. We'll say profile afterwards. We'll come to our parameters. Our depth will go multiple steps. Say our total depth will be 1/4 of an inch, 0.25. And our depth per pass, or depth per cut, will be 1/8 of an inch. You'll see it calculates to a total number of cuts of 2. We get a choice of using even depths, which gives us 2, or defined depths if we want to specify the amount of cut without rounding it off for an equal amount of cuts. Our finish, our side allowance, let's say we leave 20 thousandths for a finish pass. And bottom allowance, if any. In this case, we'll say it will cut to the bottom, we'll leave this 0, and we'll leave a side allowance of 20 thousandths for that finish pass to come back and cut. Go to our leads. On our finish pass, let's go ahead and use a circular lead. These leads only affect the finish pass. And we'll use a 1/4 inch radius. Come to our options. Gives us an option of chamfer or no chamfer. This is called for a deburring tool purpose. In this case, we'll say no chamfer. But notice as we select chamfer, it adds it to the feature. We'll come down to our posting tab. We'll use our first work offset. And then we'll move down. We'll come to our tool. In this case, we're going to use a system tool, and let's use a 5/8 tool for roughing. So we'll place 0.625, and we'll also use the system feeds. Corner radius of 0, so we'll come to our finish tool. Let's use a 1/2 inch finish tool with a corner radius of 0. We'll click OK, and we'll come to our pocket, right-click, and then left-click Compute Toolpath. And now we can see our pocket on the screen. Again, holding the Control key and using the right mouse button, I could turn the view. Let's say that these are going to be 1/4 20 tapped holes. So what we'll do is we'll come up to our milling stock, right-click, and go to Drill, and in this case, Tap. Loads our feature Drill Tap. We'd also condense our pocket by clicking the minus symbol next to it. Just make it a little bit smaller on the screen, or collapse it. Our feature Drill Tap, we'll see Geometry. I'm going to right-click Geometry and choose Reselect again. Now I'm going to pick the hole pattern. In this case, they're grouped together, so they all select when we choose one of them. I'm going to right-click, then left-click OK to confirm my selection. Now I'll right-click Drill Tap and go to Edit. Again, our rapid plane top of part. Our parameters, in this case we're going to say our effective thread depth is 1/2 of an inch. And our drill depth, let's go 0.6 so that we go through entirely through the part. We can specify if we're going to peck or use fast peck like a chip breaker cycle. In this case we're going to peck, and we'll leave the auto peck. If we choose override auto peck, we can specify the peck amounts or let the system calculate them. This will be a through hole, and our thread type is already set to 1/4 20, so we'll leave this default, and we'll use a right hand thread. We'll click Options. In this case we'll say no chamfer. Come down to our posting tab, work offset 1. Advanced posting, we'll just leave this be for now. We'll come down to our tools. Notice that the tools are already selected and these boxes are grayed out. We can either go to Manual Tool and override these settings, or go ahead and use the System tool as suggested. We'll click OK. Then right-click Drill Tap and compute the toolpath. We could also name these features. If we perform a soft double click, which would be click once on the object, wait a moment, then click again. And you'll see it, this box will become active that we can type inside of it. Let's call this our 1/4 20 tapped holes. You can name these features whatever you'd like after they've been added. I'm going to click the minus symbol. Now we're going to add the profile cut. So we'll right-click Milling Stock, Mill to Axis, and then go to Profiling. Again, right-click Geometry, this time below Feature Profile, go to Select, pick the contour that we had made, then right-click and left-click OK to confirm our selection. Now we'll right-click Profile and go to Edit. Again, our approach and entry is good. We'll do a left offset. We could also use machine comp if we choose comp left or comp right. Come to our parameters. Let's go 1/2 inch deep in multiple steps. And let's again say 1/8 per pass in even depths. Our side allowance. Let's set no side allowance. So what we'll do is we'll just perform a rough cut, or we'll use our rough cut as a finishing cut. Come to our leads. Let's do a circular lead in and a circular lead out with a 1/4 inch radius and an overlap of 0.1. Corner types. We can select different corner types for cutting around corners. In this case, we'll just use round. Posting, again, work offset 1. Advanced posting. We'll look at this in a later video. Under Tool, let's go to our Rough tool. We have a 1/2 inch tool selected, which is what we'll use in this case. And for our Finish tool, it's set to 0 because we're not going to call a secondary tool. We'll click OK, and then right-click Profile and compute the toolpath. Once we have all of our toolpaths on the screen, we're ready now to either post out the code or simulate the part. Now to simulate the part, we'd right-click Milling Stock, and then left-click Verify. And once the simulation comes up, we can click on Start, and then watch the cutter actually cut the part in the material that we had defined. The slide bar will either speed up or slow down the operations. Or we click on End to close. For posting, what we want to do is click the plus symbol that's next to the cam part. We'll come down to Milling Tools, right-click, and this will give us an option of either Post or Post and Save As. In this case, we'll Post. And our layer, UCS Post Manager, is a preview of the code which we're going to run on the machine. If you'd like to change which post processor we're using or pick a different machine, below Milling Stock we have the .milpost file. Let's choose a Fanuc. We'll right-click, then Edit, and then select a different post processor. In this case, we said that we'll grab a Fanuc post. Click Open, and then OK. Now we can either come back and post the code, or post and save the file out to be sent to the machine. That concludes this video.